We're going to start taking a look at actual theoretical probability. But quick review here in terms of experimental probability, which is what we had done the last lesson. Remember, experimental probability is where you're actually running an experiment. You're doing this thing in real life. And so in experimental probability, it's the number of successful trials for whatever it is you happen to be looking for, divided by the total number of trials. That'll give you your probability. So, for example, if you're looking at the number of times you flip a coin and you're looking for the number of times you get heads. Okay, so if you flipped a coin 30 times and you got heads 7 times, then your experimental probability would be 7 over 30. Okay, and therefore your experimental probability of getting tails would be 23 over 30. Okay, theoretical probability is different. Theoretical probability is the number of successful outcomes as a fraction of the total number of possible outcomes. Okay, so we're not necessarily looking at the number of outcomes that you get, but the number of possible outcomes that there are in total. Okay, so theoretical probability is the number of successful outcomes divided by the total number of possible outcomes. Okay, so this is what should happen in a perfect world. We know obviously that real world conditions are not perfect, and therefore, it's our experimental probability and theoretical probability are likely to be different. Okay, so let's take a look at an example here where we have a deck of cards. Okay, and so just by way of review, a standard deck of playing cards has 52 cards in it. It has 4 suits, one of hearts, spades, diamonds, and clubs. And in each suit, there are 13 cards. There's a 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Queen, Ace. Okay. So if we randomly draw one card from the deck, we want to find the probability of each event occurring. Okay, and we always want to leave these things as a fraction in lowest terms and then convert them into a decimal and a percent. Okay. So let's start off by looking at the probability of pulling out a heart. Okay, and so we know there's 52 cards in total. There's 13 cards in each suit. And so if we want to figure out the probability of getting a heart, well, there's 13 hearts out of a total of 52 cards. Okay, and so 13 of those 52 cards is going to result in a heart. Okay, and so we haven't done any experiment. We just know that 13 out of the 52 cards are all hearts, and so therefore that's what it's got to be. Okay, 13 out of 52 is actually already a fraction in lowest terms. And so let's convert this into a decimal by doing 13 divided by 52. And that gives us 0.25. Okay, and terrible looking too, so I'll just quickly erase that, try that again. So 0.25. And if we want to convert that into a percentage, we would take 0.25, multiply that by 100, and that's going to give us 25%. Okay. So if we look at situation number 2, it says, what's the probability of rolling an ace, or rather of pulling out an ace from this deck of cards? Well, again, we know that there's 52 cards in total. There are 4 suits in a standard deck of playing cards, and that means in each suit there is 1 ace. So 1 times 4 means that there's 4 aces in total. So 4 out of all 52 cards is going to result in an ace. Okay, now we can turn this into a fraction in lowest terms. Both the top number and the bottom number are both even, so we could divide them both by 2, and that would be fine. That would give us 2 over 26. But 4 and 52 are both divisible by 4 as well, and that actually results in getting an answer of 1 over 13. Okay, so if I want to convert this into a decimal, I would take 1 divided by 13, and that's going to be equal to approximately 0.077. Okay, and if I want to then convert that into a percentage, I'd multiply that by 100, okay, to get myself 7.7%. Okay. If I want to take a look at question number 3, it says, what's the probability of pulling either a heart, a club, or a jack? Okay, so I know that there are let's try that again. There are 13 hearts, there are 13 clubs and there are 13 jacks in a standard deck of cards. Okay, and this is out of a total of 52 cards. Okay, so if I add those three things together, okay, that gives me 39 cards out of 52, okay, is going to be equal to the total number of cards that is possible by. Okay, so 39 out of 52 cards is the total number of hearts, clubs, and jacks that I could potentially pull. Okay, if I put this into a fraction in lowest terms, it actually ends up being 3 over 4. Okay, because both of those numbers are divisible by 13. Okay, and so I know that 3 over 4 as a decimal is 0.75, because when I take 3 divided by 4, I get 0.75. And if I convert that into a percentage, it ends up being 75%. Okay. If I want to figure out the probability of rolling a card that is not a jack, okay, for number 4, this one's probably a little bit easy. There's two different ways I could do this. I know that there are 4 jacks in a standard deck of playing cards, 1 in each suit. So I could count up all of the other cards that would result in something other than a jack. Okay, but to simplify things, there are 52 cards in total. 4 of them are jacks. So if I subtract the jacks, that leaves me with 48 cards that are not a jack. Okay, so 48 out of 52 cards is not going to be a jack. Okay. Again, both of these numbers are divisible by 4. So 48 divided by 4 is 12. 52 divided by 4 is 13. Okay, and so 12 divided by 13, if I want to convert this into a decimal, it's going to equal approximately 0.92. Okay, and then if I want to um, change this into a percentage, okay, I would take 0.92, multiply that by 100, and that's going to equal 92%. Okay. So again, sticking with this same idea, we want to figure out, well, how many of these cards, what's the probability of pulling out a black heart? Okay. Well, it's important for us to know that in a standard deck of cards, there are 2 suits that are red and there are 2 suits that are black. Okay, the clubs and the spades are black in color, whereas the hearts and the diamonds are red in color. So if we want to figure out the number of black hearts that there are, that could be either a black club or a black spade. Okay, and there's 1 heart. Actually, let me go back. That is incorrect. There are no black hearts because it is impossible to have a black heart because all of the hearts are red. So let's make this simple. If the hearts are red in a standard deck of cards, there are no hearts or no black hearts in a standard deck of playing cards. Okay, so your probability of getting a black heart is actually 0 over 52. And so 0 over 52 as a decimal is 0.0, which as a percentage is 0%. Okay, so a little bit tricky there, certainly caught me off guard, but there are 0 black hearts in a standard deck of playing cards. Okay. So let's take a look at question number 6 there. So what is the probability of pulling out a heart, a club, or a spade? Okay, so it doesn't matter whether or not it's going to be a heart, a club, or a spade. In this particular question, it's actually very similar to question number 3. And so we know that there are 13 hearts, there are 13 clubs, and there are 13 spades. Okay, so all of that is out of 52. That means that there is a total of 39 out of 52 cards are either a heart, a club, or a spade. So the only thing you're not looking for here are diamonds. Okay, and so I can convert 39 over 52 in lowest terms. That ends up being 3 over 4, which is equal to 0.75, which is equal to 75%. Okay, so theoretical probability is looking at the number of possible outcomes divided by the number of total outcomes. Okay, and so again, the number of successful outcomes that we're looking for divided by the total number of possible outcomes is what frames our theoretical probability.